Hi everyone, in this tutorial we are going to learn how to Dockerize our Spring application and manually push it to DockerHub. To do this, first we are going to create a Docker image using a Dockerfile. Then we will test this image by running it in a Docker container. Finally, we will push this image to DockerHub manually. In the next tutorials, we will automate this process using a Jenkins CI/CD pipeline. But for now, we will focus on containerizing our project and pushing it to DockerHub. Welcome to the Tanhu Labs channel. Don't forget to subscribe to Tanhu Labs for more tutorials. We already have a service content Spring project developed using a layered architecture and a BDD approach. You can access those videos using the card. Step 1. Build the project. We need to run the maven clean command. This will remove the target directory. Then run the maven install to build the project. As you can see, a new target directory has been created. Step 2. Create a Dockerfile. We need to write a Dockerfile. Create a new directory in the project folder named Docker. Inside this directory, create a new file named Dockerfile. If you don't have the Docker plugin installed, you can install it via the JetBrains marketplace. Go to the plugins, search for Docker, and install the JetBrains Docker plugin. Step 3. Writing the Docker file. We must specify the base image version in the first line. From OpenJDK 21 JDK Slim as built. This is a lightweight version of OpenJDK 21, which includes only the necessary components to run Java application. The as built part names this stage build, which helps separate the build process from the final image. The second line sets the workings directory inside the container, workdir/app. This means that all subsequent commands will run inside /app. Keep in mind that this directory exists inside the container, not on your local machine. I will show you this directory after running a container from this image. Next, we must copy our application jar file into the app directory. Our jar file is located in the target directory. In this project, the application jar is named service content 1.0 snapshot jar. So we copy it using copy command. Now we define the entry point for the container. It specifies the default command that will run when the container starts. If we name our jar file something different, we must update this line accordingly. For example, if we rename app.jar to tanhu.jar, we need to modify the entry point line like this. The final line is expose 8080. This indicates that the container will listen on port 8080 at runtime. It does not map the port to the host system, but serves as documentation for users to know which port the service runs on. Step 4. Building the Docker image. Now we are ready to build our Docker image. Before proceeding, ensure that Docker engine is running. Open the terminal and run the command docker build -t service content -f docker/dockerfile dot. -t service content assigns the image a tag. -f docker/dockerfile specifies the path to the Docker file. Dot refers to the build context, which is the project directory. Press enter and the image will be built. After building the image, go to the Docker desktop image page. As you can see, we have a service content image. Now we need to run this image inside a container. Step 5. Create a Docker compose file. Go back to the project and create a Docker compose file. Service section defines all the containers that you want to include in your multi-container application. Service content acts as an identifier for this service and can be used later to refer to the container. This name can be anything you choose, but typically it is the name of the service or application. Image service content latest specifies the Docker image to be used for creating the container. Service content latest refers to the image named service content with the latest tag. The latest tag indicates that Docker will use the most recent version of the service content image available. The ports section defines the port mappings between the host machine and the container. In this case, port 8500 on the host machine will be mapped to 8080 inside the container. I choose a port other than 8080 because it is a commonly used port and we might encounter port binding exception when using it. Step 6. Run the container. Now let's run the container using Docker Compose. Open a terminal and type docker compose -f service content.yaml -p myapp up-d. Docker Compose used to define the manage multi-container Docker applications. -f service content.yaml specifies the path to the Docker Compose file. -p myapp sets the project name for Docker Compose application. In this case, the project name is myapp. Up starts the service defined in the Docker Compose file. It creates and starts containers for the service specified in the service content.yaml. -d stands for detach mode, meaning Docker Compose will run the containers in the background, freeing up the terminal for other tasks. Step 7. Inspect the running container. Go to the Docker desktop and click on the service content container inside the myapp project. In the logs section, you can track application logs. Switch from logs to exec to execute Linux commands inside the service content container. Run ls. You should see a file named tanhu.jar. This file was copied when we built the Docker image using the Dockerfile. We specified the working directory with workdir/app. Since we are inside the app directory, let's navigate to the parent directory. cd /ls. These are the files inside our container. Now return to the app directory. cd app. ls. Here the tanhu.jar file corresponds to the service content 1.0 snapshot jar file from the project's target directory. Step 8. Test the application with Postman. Now we need to test our project using Postman. Send a post request to create a new content entry at localhost 8500/API/v1/content. If everything is working correctly, we should receive a 201 created response. Push the image to DockerHub. After testing, we need to push this image to DockerHub. Today we will do this manually, but in a future video we will automate the process using a Jenkins CI/CD pipeline. If you want to watch that tutorial, don't forget to subscribe to the Tanhu Labs channel. First, you need a DockerHub account. You can create one easily by signing up with your email address. Then sign into your account via Docker Desktop. To push the image to DockerHub, we first need to tag it. Docker tag service content tanhulabs/service content latest. This command takes the existing service content image with a new name, organizing it under the Tanhu Labs namespace. Now push the image to DockerHub. Docker push tanhulabs/service content latest. Once the push is complete, the image will be available on DockerHub. To demonstrate this, I will create a new Docker Compose file in the next step. Before running the new container, I am removing the previous service content container and image to ensure a clear explanation. Now run the following command: docker compose -f service content dockerhub.yaml -p dockerhub up-d. This command will download the service content image from DockerHub to your local machine and run it inside a container. You can find all the source code for the service content project on the Tanhu Labs GitHub account. For Docker image, you can check out the Tanhu Labs DockerHub repository. If you enjoyed this video, don't forget to hit the like button. See you in the next video. Goodbye.